In this video, I want to give you a quick overview of how a solar cell works, but also cover a little bit how a diode is actually created. So in this image, you see two little blocks, and they're going to be representing our two doped semiconductors. In this case, we have an N-type semiconductor, and we have a P-type semiconductor. Now, if you remember, the N-type semiconductor is where we have no holes in the valency band, and we have lots of electrons almost in the conduction band. It doesn't take much all amount of energy for them to move into the conduction band. So the predominant charge carrier are electrons. Of course, in the p-type semiconductor, being doped with a 3 valency atoms, then we have holes, positive holes in the valency band being the predominant charge carrier. So what happens, of course, is when we stick these two together like this, something strange happens. And what happens here is called the depletion zone. Now let me explain briefly what this depletion zone actually is. So as you know, we've got electrons here that are in the conduction band. And these electrons over here in the conduction band tend to have a tendency to move to a lower energy level, and they can if they drop into the holes that are already here into this p-type semiconductor. So what you're going to get is you're going to gradual movement of some electrons from the N-type to the P-type. And this area here is called a depletion zone, because in some ways we are depleting the electrons from this region over here. But if you now know what this area here normally is still neutral, even though we have electrons here. This area is normally still neutral, even though we have holes here. And so by actually having electrons migrate across from the N-type to the P-type, you're now going to set up an electric field, because this region here now, because it's lost some electrons, has become slightly positively charged. Whereas this region here becomes slightly negatively charged because of the movement of the electrons. And so as a result, we can look at one of two ways. First of all, since this is a slightly positive charge, slightly negative charge, we can see that what we're setting up here is an electric field that runs in this direction from the positive to the negative. And so as more electrons go across, this electric field increases, which in essence slows down the migration of electrons going across, because these electrons will not move naturally in the direction of the electric field, they'll move naturally in the opposite direction. And so that's one way of looking at it. But also the way you can look at it is that you're setting up a potential difference. So now we've got an N-type and a P-type joined together, but at the zone here, the depletion zone, we have set up an electric field. And in essence, that is actually also how we create a diode. So if I were to apply an alternating current to this, an alternating current, of course, means the electrons moving in alternating directions. But what this actually does is that the electrons will move in one direction, and so they would move, let's say, in that direction quite comfortably. However, as soon as the potential difference changes here, the electrons would, this potential difference would want the electrons to move in the opposite direction, but of course what happens is that the electric field prevents this. And so in essence, what this setup does actually is rectifies an alternating current. It actually makes it a direct current. So that in essence is the beginning of a diode. But what about creating a solar cell out of this? So we've got the same situation here, but what we're now going to do is we're going to shine some light on this. And the other thing we're going to do is we're going to actually set up the circuit again. So now we're going to get two different effects. First of all, we're going to get the photoelectric effect. And the photoelectric effect, of course, is when you have photons flowing onto the semiconductors, and that will automatically cause electrons to be released from the surface, as long, of course, that the work function is overcome. In other words, that the amount of energy from each of these photons, because HF, is greater than the work function. So these electrons, they will therefore have some kinetic energy left over. Now, we've got, of course, electrons being released, and these electrons then, of course, are free to move. Now, of course, they can remove them in random directions, but the one problem is of course, is that this electric field that is set up here between the N-type and the P-type prevents any electrons moving in that direction over here. And so the only natural conclusion is that the electrons will start to move around the circuit. And of course, what happens, of course, is in this case, this represents a light bulb, and that light bulb will start working as the current starts to flow through it, because that is what the electrons do. Now, it's a little bit ironic. We've got a solar cell here generating electricity to make a light bulb work, but nonetheless, we're getting a flow, and it's a direct current flow. Now, what's happened here, of course, is that we have electrons definitely moving across there, but we also have a migration of holes going in the other direction. And so, as you know, that when we have a movement of current, the current is contributed by two types of charge carriers, the electron flow in one direction and the holes in the other direction. And so as the holes go in this direction, of course, that is due to the electrons, so to speak, moving one by one across within the valency band. And so this therefore sets up a nice direct circuit. So in summary, a solar cell ultimately is really a function of two important physics principles. The depletion zone set up by an N-type and a P-type semiconductor. And secondly, the photoelectric effect, where electrons are released, and by the fact that the photons cause electrons to be liberated, and the setup of the electric field in the semiconductor causes the electrons to flow in one direction. I hope that gives you a better understanding of how a solar cell works.